Hi everyone, in this video, we are going to talk about set theory again. In the last video, we have already talked about number systems, definition and basic notation, what is a subset, and the union and intersection of two sets. The topics that are going to cover in this video would be more notations of sets and Venn diagrams and their implication on sets. So more notations. The first one is always a slash in it, which represents the empty set. That is essentially a set with no elements. The second one is the set name apostrophe, which represents the complement set of the set A. In order to understand what is a complement, we must understand what is a universal set, which is denoted as a capital U. A universal set is essentially everything. So a complement set is that a set with elements that is not in the original set, but in the universal set. So let's take a look at an example. Determine the complement of C if the universal set is Z and C is X such that X is 2N and N is also Z. So to recap, Z denotes integers. And set building notations, which is shown right here, is a set name is a variable with conditions. So, in order to solve this question, our first step would be what element would set C include? So if Z is an integer, which is from negative infinity, -2, -1, 0, 1, 2, and so on, what element would set C include if C equal to X, where X is 2N, and N is all the integers? So if we use 2 to multiply with every single integers here, what would we get? The answer is all the even numbers. That is still from negative infinity to -4, -2, 0, 2, 4, and so on. Our next step would be, what about using Venn diagram to visualize the relationship between the complement of C, the universal set, and C? So we have 3 elements that we want to fit into this Venn diagram. Set C, the complement set of C, and the universal set. To recap, C, as we got right here, is all the even numbers. The complement of C, we still don't know, and the universal set is all the integers. So the universal set should be the whole square, the bigger rectangle right here, which includes everything. And it includes the set C, which is this circle, and everything that is not in this circle, that is not in the set C, but that is in the universal set, is the complement of C. So after visualizing the relationship between these 3 factors, conceptually, what would the complement of C denote? So the complement of C would be a number that is not an even number, because that is not in C, but an integer. So one number that is not an even number, but an integer. So we can clearly see that a number that is an even number but not an even number but an integer is an odd number. So how can we, using set building notation, to denote the complement of C? So the complement of C would be X such that X is equal to 2n plus 1, which is the common denotation of an odd number, and n is a member of integer. With this notation, we can include all the odd numbers, and that is exactly what the complement of C denotes. So that's all for extra notations and its examples. Next, we are going to talk about Venn diagrams and sets. So first, we need to understand what is the function of Venn diagrams. So the function of a Venn diagram is to visualize relationships between sets. So let's take a look at some example questions. So the first question is a recap from the last video. How can we use a Venn diagram to denote subset B of A? So if we have a set that is B, that is a subset of A. So A includes B. So we can use a bigger circle to include B. So this would be the Venn diagram for this scenario. B is a subset of A. Next question. What is A union B plus A intersect B? So first of all, we must have two sets. So we usually use a rectangle to denote the universal set. That could be anything. That is basically everything. And then we have two sets. And right here, we use two circles to denote those two. So let's say on the left side, this circle denotes A, and on the right side, this circle denotes B. So what is A union B? Which kind of area denotes A union B? That will be anything that is either in A or in B. That is what we covered in the last video. So that would be anything that is highlighted in red. Right? Next, what is A intersection B? What would be the area that is A intersect B? That is the elements that is both in A and in B. So that would be the central overlapping area covered in green. So these two are the concept of union and intersection, which are both covered in the last video. Next, what is a complement of A? As we talked in the last part of this video, a complement of A is that anything that is not in A, but in the universal set. So that is everything that is in the red color painting. Question D. What is A intersect B intersect C? So this would be a bit more tricky. So we still, as we can see, we have three sets here, A, B, and C. So first, we always use a rectangular set to denote the union set. Next, we need three circles to denote these three sets that we know right here, which are A, B, and C. So we can use this circle to denote A, this circle to denote B, and this circle to denote C. So, what is A intersect B intersect C? So conceptually, we can see that this is all the elements that are in set A and set B and set C. So visually, it should be the overlapping area of the three circles. So which is the central overlapping area right here. that is in set A and in set B and in set C at the same time, because it is in the 3 circles at the same time, if you look closely. Next question. A intersects with the complement of B. So the first step is always to draw the universal set and the set that we have in the question without determining the relationships. So we know that we have a universal set, we have a set A, let's use this circle, and we have a set B, let's use the right side circle. So we know that we are aiming to find the intersection between A and the complement of B. So in this graph, the only thing that we still have not yet found is the complement of B. So we can highlight the complement of B first. So as we know, the complement of B should be the area that is not in B but in universal set. So anything that is in the universal set but not in B, which is the part that I'm painting in red color. Anything universal set but not in the set B. Next, we want to find what's the intersection, which is basically the overlapping area, between set A and the complement of set B. So anything between set A and the red paint. What is the overlapping area between these two? And we can clearly see that is the part that I'm drawing with the green paint. That is the overlapping area between set A, which is this circle right here, and the red paint, which is what I'm drawing with the green paint here. Next, we're going to look at a few harder examples. So the first one is A intersect with B union C. So first thing first, we always use a rectangular set to denote the universal set. And then we put all the set that we know right here into this diagram. So we have set A, we have set B, and we have set C. Set A, set B, set C. So we want to find, just like the order of operations, we usually work from inside the bracket to the outside of bracket. So firstly, we want to find what is B union C. So B union C should be anything either in set B or set C. So that is anything. So if we unite the set B and set C, these two sets, we would get something like this that is being highlighted in red color. Next, we want to find what is the intersection, which is what is the overlapping area between set B and B union C. So still, we want to find the overlapping area between set A and the red paint. So as we can see, this is set A, and these are the red paint. So what would be the overlapping area? And we can clearly see that would be the part that I'm painting in green. Those would be the overlapping area between set A and B union C. That is, A intersects B union C in bracket. Next, the complement of A union B. So still, our first order of business would be to draw the union set and put set A and set B into the union set. So still, we work from the bracket first. So bracket first. What is A union B? That is the area if we unite the two sets together, just like this. This should be fairly simple. And what is its complement? So anything that is not the red paint, but in the universal set, which is in the rectangular area. So anything that is not the red paint, but in the rectangular shape, which is the thing that is outside the united red paint of set A and set B, which I'm painting in green right now. So anything that is outside of the unifying set of A and B, which is the A union B, but in universal set. So not in the red paint, but in the universal set. Next, bracket A intersect B, union bracket A intersect C. So this one is a bit trickier, and let's try to solve it together. So first, we need the universal set as usual. And we have 3 sets, so let's put 3 circles here to represent the 3 sets. So this one, set A, set B, set C. So still, our first priority would be the bracket. So we have 2 brackets here, so let's try to find them respectively. The first one, A intersect B. So that is the overlapping area between the circle representing A and the circle representing B. That would be the central overlapping area right here. Next circle is A intersect C. So that would be the intersecting area between the circle representing A and the circle representing C. That would be the area right here, which is the central overlapping part of the circle of A and the circle representing C. Let me just make this red appearing again. And then we want to find the union between these 2 areas, one in red paint and one in green paint. So union simply means a unification. So if we unite these 2 areas, we should ideally get the union between A intersect B and A intersect C. So that is all the area that is in this shape. All in this shape, because that is all the red paint and green paint area. Next one is the complement of A intersects the complement of B. So let me just put the universal set here real quick. And this question, we only get 2 sets. So it should be simpler. So what is the complement of A? That should be anything that is not in A, but in the universal set. So that is anything that is in red paint. Oops. We shouldn't include anything in set A. Anything red paint. Next, we want to find what is the complement of B. So anything that is not in B, but in the universal set. So that is essentially anything that is in green paint. After that, we want to find the intersection, which is the overlapping area between red paint and green paint. So which part of this diagram has both red paint and green paint in it? If it does, then that's the part we are looking for. So after close examination, we would find that any part that is painted in white has both green and red paint in it. If it only has one color, we don't want that part. Oops. So that is any parts that is in white paint. This part as well. This part. Okay. Last question. A reverse slash bracket B intersect C. So in this question, introduce another symbol, this reverse slash. That means without. So A without this thing. So before, let's just put our universal set and the three sets in the diagram first. So this is the universal set, and we have set A, set B, and set C right here. So set A, set B, and set C. So still our priority is bracket first. So let's take a look at the bracket. So what would be A, B intersect C? That should be fairly simple at this point. So that's the overlapping area between the circle B and circle C. So what would be A without this part? That is simply means elements in set C, but not in B intersect C. So without means the elements in this set, but not in this part. So let's just outline set C first. So you want any elements that is in this part, in the white circle, but not in the red paint. So that is basically anything that is in the white circle, but not the red paint. That will be anything that I am painting in green right now. So if we want to outline the part that we are looking for, that should be anything that is in red paint. But we don't want the red paint, so we exclude it, and anything just like this. I think that's all for this video. Thank you for watching and have a good day.